Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Alex. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
All right, thanks for taking care of that, Alex. So where do you go to school?
Panama,
What grade are you in?
4th grade.
Do you like 4th grade?
Yeah.
Do you think you're ready for 5th grade right now?
Yeah.
Yeah, there you go, brother. You think you're ready for 6th grade right now?
Kind of.
Kind of. Well, you know what? That's good. That's a great attitude to have, right? Like you are ready. So you're dominating 4th grade? Has anything in 4th grade given you any difficulty yet this year?
No. Not
Okay. So how's the math going? Pretty well?
Yeah.
What kinds of things do you do in science? Do you guys do a lot of science in 4th grade?
No.
Not yet? Do you do missions or anything as far as history?
No.
Not yet. And what about reading? Do you guys do certain stories or books, or do you just do kind of reading and English language arts all together?
Kind of all together.
Kind of all together? So what about, now, do you guys do art and PE also in 4th
Yeah.
grade? And what kinds of activities do you do for those?
PE, I do sports like football, PE. And in art, we usually just do like crafts and stuff.
Okay, so you like everything about 4th grade? You like going to school a little bit longer than you did last year? Good. Are you ready to do a social media problem with me today? All right, let's take a look at it together. So it says the problem of the day, what are the prime factors for 12? So when you see that question, what pops into your mind? What do you think of when you see that? Is there anything that you understand or don't understand or are wondering what it means?
Just wondering what the prime factors, kind of.
Okay, so prime factors. So have you ever heard of prime and composite numbers?
Yes.
What can you tell me about prime and composite numbers?
Composite numbers are usually even.
Okay.
2 is the only prime and composite number. Prime numbers are usually odd.
Usually,
Very true.
but there can be odd composite numbers. Think about 21. So what would make a number prime? So is 3 prime or composite?
Prime,
Why?
because it can only be multiplied by itself.
Right, only
times the
1
number.
and itself is the only number. Those are the only factors that go into 3 are 1 and itself. What about 7?
7, 1 in itself.
Okay, now what about 9? Because that's an odd number.
1 itself and 3 and 3.
So that would make it composite.
Yes.
So we're good?
Yeah.
All right, so prime are numbers that are prime, okay? And then factors are numbers that go into a number. So can you think of numbers that would go into 10, other than 1 and 10?
2, 5.
Right, so 1, 2, 5, and 10 are all factors of 10. They all go into 10. Does that make sense? All right, so we're gonna look for factors of 12. Now, if we multiply those numbers, 2 times 2 times 3, what do we get?
12.
Okay, so let's look at B, 12 times 1, what do we get?
12.
Okay, well, let's look at C, 3 times 4.
12.
Well, we're on a roll of 12s, aren't we? All right, so let's take a look at D, 2 times 3.
6.
All right, so can we eliminate any one of those so far? Because we want to
D.
see things that multiply to get 12.
You could take away D.
We can take away D. Now so we know that all of those numbers up there, other than D, those are all factors of 12, but we want prime factors. So which one do you think would make all of the numbers in that option prime?
3.
So let's take a look at A. Is 2 a prime number?
No.
What can go into 2 besides 1 and 2? Nothing can, can it? Oh, ooh, there you go, right? So 2 is a prime number, right? What about 3? Is 3 a prime number?
Yes.
Yeah, you said that earlier, right? Let's go down to B, 12. Is 12 a prime number?
No.
No, so we can probably eliminate B, because that has more numbers than just 2, okay? What about C? What do you think about those 2 numbers? Are they both
4?
prime?
No.
Which one isn't?
4.
Why?
Because it can be multiplied by 2 and 2 and,
Okay,
and
good.
1 in itself.
All right, so taking a look at the question, what are the prime factors for 12? Which one do you think is the best option?
A.
All right, let's take a look and see if indeed A is the correct option. There you go, dude, first one done. See how easy that was? A nice explanation about prime and composite right there. Hey, we do have phone tutors available most Tuesdays and Wednesdays between 3:30 and 5:30. Phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News. All right, and today's Math in the News, we dealt a little bit with prime factors, and our Math in the News today is dealing with the largest prime number. So prime numbers, I mean, they're hard because it's only one and itself. So to find a large prime number takes a lot of work. And this recently came out that we have a new largest prime number that has been found. So once again, as Alex was saying, a prime number is a number that has only 2 factors, 1 and itself. A composite number, like 6, has other numbers besides 1 and 6 because 2 and 3 are also factors of that number 6, so therefore it is a composite number. Moving on, the largest prime number is 2 with this very large exponent, 136,279,841. That's how many times you are raising the power of 2. And you're doing all of that and subtracting 1 from your answer. So you're going 2 times 2 times 2 times 2 times 2 times 2 times 2 over 136 million times. And you're going to keep multiplying that. And then at the end of it, you're going to subtract 1. That is going to be the largest known prime number at this time on November 13th, 2024. Now, how was it discovered? Well, this isn't going to be somebody who does multiplying 2 all the way out and spending a long, I don't even know if you would be able to do it with that amount of 2s. So what they're doing is using graphic processing units, and this guy Durant, 17 different countries had computers working on this, and after about a year, they came up with this number, which is now the largest prime number. So, exponents. We saw that very large exponent to the 136 million and all the other numbers after it. So an example of how exponents work, 3 to the 5th power is not 3 times 5, where a lot of students get confused and they go 3 to the 5th is 15, but it's actually 3, which is the base. 5 is the exponent, so we're multiplying 3 5 times. So we're taking 3, writing it out 5 different times, and when you do that, we can see that we come out to 243. So it's not 15, it's 243. Now we'll take a look and see what's 4 to the 6th power. So now we have 4, and we're going to raise it to the 6th power, which is equal to 4 times 4 times 4 times 4 times 4 times 4. Now, if you know your 4s, that's good because you're going to have to multiply 4 a lot of times. Instead of doing it a lot of different times, what we can do is we can break it up. We can go 4 times 4 is 16 times 16 times 16. So now we're just going 16 times 16 times 16, which is only 3 numbers instead of 6 numbers. Now, if you're really good with your 4s, you can even break it up again, and you can simply go 3 4s, which is 4 times 4 times 4, so 16 times 4 would be 64. Do it again 3 times, so it would be 64 times 64. Either way you do it, you are still going to come out with the same answer of 4,096 when you have 4 to the 6th power. And one way that you can kind of think about this is that you're raising it to a 6th. It's going to end, this instance, it's going to end in a 6. That is today's Math in the News. We'll be back with more right after this.
Everybody, welcome back. Today we're looking at some other different patterns in math. A lot of times, I teach 6th grade, for example. A lot of students are dealing with unit rates, different inputs and outputs that are later used in algebraic equations, 7th and 8th grade. Let's take a look at some of those examples you may see now that you can play with to start getting an idea of how to look at patterns and identify them in a simplified setting. So we notice we have some numbers here, 5, 10, 20, 35, 55, 80. Not a very obvious pattern, but let's see what we can find. Let's see, from 5 to become 10, I could multiply by 2. That checks out. 5 times 2 is 10. 10 to become 20. Hey, that checks out again. Times 2. 20 by 2. We have a problem, don't we? 20 by 2 is not 35. So let's go back to the drawing board. What else can we find? Well, 5 to become a 10. Can't multiply anymore. Simply not going to divide. What about adding? Okay, 5 plus 5 gives me 10. 10 plus 5. Oop. Not 20. So what else can we do? This added 5. Well, to make 10 become a 20, that would have to add 10. Okay, 5, 10. I notice a pattern here. 5, 10. What about 15? Counting by 5s. 20 plus 15 does make 35. If I continue my patterns of 5, 5, 10, 15, 20 now. Okay, 35 plus 20 does make 55. Continue our patterns of 5. 5, 10, 15, 20, 25. Very nice. There we go. Add 25. 55 and 25 does give us 80. So what's our pattern here? These are all different numbers. Mickey, this isn't a pattern, but it is. We're noticing we're increasing by values of 5 as we continue to go up. We first added 5, then 10, 15, 20, 25. Not the most common. Students will say it's always adding by 5, always adding by 10, or by 7, or by 6, or whatever number it might be. Sometimes as you get into the older grades, 7th and 8th grade, it's an exponential growth that's controlled. So that's one example. Let's look at another example here. We have 3, 6, 12. All right, we pause here, take a look at this one. We have 3, 6, 12, 21, 33. They look like they have nothing in common other than the fact that they're multiples of 3, so it might have something to do with 3, so let's take a crack at that first. 3 to become 6, hey, that's times 2. 6 to become 12, hey, that's times 2 also. Wait a minute, we had that first up here, so there might be some other pattern here that maybe you're picking up on at home. See if you can pick it up as well as we continue on. But 12 times 2 is not 21, just like the 5s, multiplied by 2 for the first two, but after that it didn't work. So let's try our example from before. We added 5, 5 make 10. How do I make 3 become a 6? Let's add a 3. Okay, well, 5 went to 10. It was the next multiple. Let's go to the next multiple of 3. 3, also add 6. 6 plus 6 is 12. Next multiple, 5, 10, 15. Do the same thing. 3, 6, 9 now. I add 9. 12 and 9 is 21. 3, 6, 9. What's our next one? 12. Very good. Add 12. 21 and 12 does give me 33. So we notice again another pattern, even though it's not the same counting by 5s, just like before. It didn't end up being counting by 5s. It was counting by exponential increases or multiples of 5. Down here we see the same concept, but now with multiples of 3 increasing in value. Again, we see an exponential growth. Those of you students going from 6th to 7th to 8th or even 9th grade, you'll begin to see algebraic expressions not just using the same pattern over and over, but we see there's a relationship between the pattern that's a little more advanced, requires you to think a little deeper into the box, but it's always possible. Just be comfortable with patterns and see what you find, see if it works.
There we go. Thanks to Mick for that one. And number patterns, and that's all math is. Did you know that? That's simply all it is. It is number patterns. It is patterns, and you simply have to find the pattern with the problem that they're talking about. And when you're able to distinguish let's say, more complicated patterns, that's the higher level math that you'll be able to do. So all of the math that you've been doing ever since TK, that's when you started going to school, right? And all the math courses that you've been taking and all the different math that you've been learning, it's all math patterns. Think about multiplication, right? What would you like to count by? 2s, 3s, 4s, 5s, 10s, hundreds, 88ths? What would you like to count by?
5.
5s, all right. So go ahead and count by 5s for me a little bit.
5, 10, 15, 20, 25, 30, 35, 40, 45,
Keep going. You got
50,
the girls doing a little bop over there.
55, 60, 65, 70, 75, 80.
All right, good. You can stop there for a minute. Okay, otherwise, they're going to get too going over there and stuff like that. So that was a pattern. What was the pattern?
5.
Counting by 5s, right? So a lot of things, all they are is patterns. You just need to find the pattern. Does that make sense? All right, so we're going to do something right now, and you're going to see if you can find a pattern, because maybe that'll help you. All right? So this is one of the problems that you're working on for your math homework. So it's already on the board, so you and Cece are going to work on it together. So Alex, head over there and explain to Cece how you would like to solve that problem.
All right, so what are we doing here? What's our goal?
To find the missing number.
Okay, so we're filling in the box. Okay, so we're something times 7 plus 7 is supposed to give me this number over here, right? Okay, so what did you do? You say you've already done this problem before?
Yes, it's on my homework.
Okay, so show me what it was that you did.
So I just subtracted 7 from this.
And why are you subtracting 7? Because it says a plus 7 over there.
I know, so then I can multiply this to get that, and then add the 7, which will equal it.
Okay, so like he was talking about, we know that it's patterns. We know that it's a balance. This is always a balance. So if we're going to take something off of this side, we have to take it off of this side too, right? Okay, so we're going to subtract. So go ahead and show me that you subtracted the 7 over there as well. So just do just like you did this minus 7, show me minus 7 over there. Okay, good. So some people think they're canceling things. They use the word cancel a lot, right? No, we're subtracting. We're getting it down to 0 so that we're just left with this. So go ahead and show me our new equation.
7. 7 times 100, no, 1,470.
Okay.
No, divide that.
Why are we going to divide now? You're like magically coming up with stuff. This is a multiplication. How come we're dividing?
Because 7 times something equals that.
Okay.
So I'd have to divide that to find what's in here.
Oh, good. Okay, so we're going to undo our multiplication, right? We're going to say we know that if something times 7 gives me this, that if I do a division, then we can get down to that number. Okay, so then go ahead and show me that division.
I have to do that right here.
Okay. Okay, so 0 because it doesn't go into 1?
Yeah.
Okay. Well, we bring down the 4 and 7 goes into 14. Nice. And bring down the 7. Nicely done. Okay. So what's my answer?
210.
210. Okay, do you know you just did algebra? That's something that you're going to like
Right,
do a
so
lot of in
Cece,
junior
here's what I
high?
want you to do.
Yeah.
Right, because that's exactly where I was going to go
Yeah.
after seeing how he approached this problem. So you got 210 as your answer, all right? And you knew that you had to eliminate the number on the one side, and you did it on both sides, right? And then you had to get rid of the multiplying 7. You did the opposite. You divided by 7. So clear the board. I've got a beautiful problem for you right now.
Okay, so we'll go ahead and we're just going to give ourselves another. Oh, no, just kidding. I just broke it. I just broke it! I just broke it!
You just need to make it big again. No, yep. So you see where the little arrows are at the bottom?
Yes, I'm going to do that.
Now let's
There we go.
There we go. I'm going to press the.
add
There we go.
plus button.
I did, and then it didn't.
So that you have to, yeah, and then you'll just hit whiteboard.
Okay. Okay.
All right, here we go. 6n. So you're going to write this up there. For me.
Okay, all right.
6n minus 7 equals 17. All right, Alex, this is what you're going to do when you're in junior high school. But you just did a problem like that in 4th grade.
Now you look like you're worried. So I'm going to help you out. I'm going to take this n because what we're trying to solve for is we're trying to solve for n. I'm going to give you a box just like you had in your homework. So now I show you I have something times 6 minus 7 gives me 17. Does that help at all? That make it a little bit better?
6.
6 times something minus 7 needs to give me the 17. What was the first thing you did in that other problem? You subtracted off the 7, right? Okay, here I've got a subtraction. I'm subtracting 7. So what am I going to do to undo subtraction of 7? What undoes subtraction? What undid addition? It was a plus 7, right? What did you do?
Subtract the 7.
So if I've got a subtraction of 7, what am I going to do?
Plus.
Aha, that's right. I'm going to add 7. So I'm going to do a plus 7 there. Go ahead and show me that plus 7. Yep, just plus 7 right underneath it. Yep, and what you do to one side, you have to do to the other side. So plus 7 over here. Perfect. Okay, so now, you probably haven't done a lot with negatives, have you? Or have you done much with negatives?
Not really.
Okay, so this is the same thing as saying like subtracting 7. So I'm in the hole, like I owe somebody $7, right? So that's my negative numbers. I owe money. I owe somebody negative $7, or I owe somebody $7. I get $7. So I pay them off. How much money do I have left?
0.
Ah, nicely done. Okay, so I know that this is 0. Just like when you subtracted the 7, you had a 0. So my negative 7, or I'm in the hole, I owe money 7, I get 7, I pay him off, I've got 0. So now I've got 6 times something. So go ahead and we're going to rewrite our problem. We're going to do 6 times something. And we can do it 6 in a box, or we can do it 6 in an n like he had
I'm
before.
going to do like this way, or
Yeah, no, 6, and then do your little box. There we go. Good. Is equal to.
course.
Now, 17 plus 7 is?
$24.
Perfect. Okay, so now I've got 6 times something gives me 24. What's my something?
4.
Nice. I know I have a 4 right there. So look at what we could do. I'm going to check it. 6 times 4 gives me?
24.
Minus 7 gives me?
24 minus 7.
There, you can do it. So 24 minus 7. Go ahead. And look, 17.
Oh, yeah.
Yeah, so you say, oh, at the end, right? So I'm
There it
glad.
is.
So, Alex, did you struggle a little bit with that problem? Perfect. That is exactly what I wanted you to do. Because by you struggling and having to think a little bit about that, when you start doing these, you're going to think back and you're going to go, you know what, this was the same thing as what I did in 4th grade. You just did it with a box instead of a letter or a variable. You're doing the same thing, right? All you're doing is essentially you're adding, subtracting, multiplying, and dividing. Mm-hmm. You just have to find the pattern and the order in which to do them. You feel pretty good after doing that one, though? You're doing problems that 7th graders are doing right now. And you're taking care of this in 4th grade. Nicely done. For a great problem right there, you've got yourself a pass to any athletics event at CSUB, courtesy of CSUB Athletics. So hopefully you have an opportunity to go out and see a game sometime this year. We'll be back with more right after this.
How do spacecraft slow down? Well, there are primarily 2 methods of thought for how spacecraft slow down, and you really have to ask yourself, are we landing in an area that has an atmosphere? If not, you definitely want to go with retropropulsion, where you use retro thrusters pointed down at the surface of the planet to slow yourself down as you're coming in. If you do have an atmosphere, that makes it a lot easier, as the atmosphere acts as kind of a giant brake as you slow down. So you have your missions like Apollo that used retropropulsion when we went to the moon. When you're able to use the atmosphere, you have your heat shield on the blunt end of your spacecraft coming into the atmosphere, and then the parachutes will come out and slow you down the rest of the way to provide that safe landing. Here at NASA, we're constantly developing new technologies to help with that entry, descent, and landing, or EDL. Some of the trick in entering atmosphere is when you do have it, but it's really thin. One of the technologies NASA is developing to handle those is called HIAD, Hypersonic Inflatable Aerodynamic Decelerator. The HIAD can come as a heat shield much like the blunt body heat shields of those older missions that were made out of ceramics or metals and were very hard. However, HIAD is a flexible woven system that compacts really, really small. So you're able to actually get a very small heat shield inside your rocket diameter. With HIAD, when the fairing comes off, the heat shield can then inflate and expand to a diameter much larger than your rocket. Therefore, you're able to bring in a much larger payload than you were before. So how do spacecraft slow down? You have retro propulsion, you've got your rigid aeroshells and parachutes, and coming soon, we've got these inflatable heat shields.
All right, once again, fortunate enough to have Julie in studio with us. How are you today?
I'm great. How are you?
I'm excellent now that you're here, and I can see you brought all of your footwear with you.
I did.
But before we get to all of the footwear, what is your role with the Kern County Superintendent of Schools office?
Well, I'm retired. In 2016, I was an employee here for 34 years, and now I am an early childhood education consultant
So
for the
you are a
office.
consultant.
I am a consultant.
So you're using your years of expertise to help others gain their expertise.
Right. It was, I have a real passion for early education, and so I wanted to use that passion still.
There you go. And early education, so what ages are we talking about?
0 to 8.
Okay, so as soon as they're born, they're learning.
You bet.
Even though they can't let us know how they're learning, they are learning, they're absorbing, they're just sponges. I mean,
They are.
we're always sponges, right? I mean, we're constantly learning all the time. But those formative years, it's happening at a greater rate.
Between 0 and 5 is when you have the greatest brain development also. So, any interactions, any activities, experiences that you give children at that age are connecting all of those synapses
Right.
in the brain.
Perfect,
Right.
perfect example. I'm glad you brought that up because it's all brand new to them.
Yes.
Right? So those
Yeah.
new experiences, those new struggles, those new challenges, that's what's firing everything, which is why we had Alex try that new problem today. He has more brain growth going on during that 5 minutes than he could ever imagine was going on.
And he did a great job.
He did indeed. All right, so let's go ahead and talk about measurement today.
We're going to talk about measurement and the fact that, young children, measurement is everywhere. They can measure anything in the environment that they have the opportunity to. So it's just about giving them the tools. And when we talk about measurement, it's not just about measuring things, but it's the language. The language-rich vocabulary that we want children to understand. Big, small, medium, large, all of those words that help children understand measurement.
And expands their vocabulary at the
Oh,
same time.
absolutely.
And using things other than just inch, foot, yard,
Right.
things like that, different units of measurement, different things that they have, objects that they can use.
Absolutely, absolutely. I mean, there's the standard, tools that we want to definitely introduce to
So they're
children.
familiar with them.
Right, yardsticks, rulers. Children love, tape measures because they, go in and out. They love that. But we want to introduce those things, but how they use them might be a little different in early education. But it's about learning about them and learning about what the numbers mean.
And I know we've got some videos, so let's take a
Yeah.
look at one of the first ones right
Okay.
here. And what's going, this is in a classroom.
This is in actually a transitional kindergarten classroom where the children were building with blocks, as you can see, and the teacher grabbed a yardstick and started to measure that with the children. So it gives them another dimension to that activity. She also, because I was in the classroom at the time, she also measured them according to the children. So is this taller than you?
Okay.
Or are you taller? Or are the blocks taller? So it's not just using the
So
measuring
are
tools,
there
but using the children themselves.
Things like estimation going on, I'm sure, as well. So one of the students, the kids might go, I see the tall tower of blocks, and they might estimate, well, that's more than one yardstick.
They can do that. Well, as you noticed in the activity with the blocks, she had to move the yardstick up so they can see that, oh, it's not just one yardstick, but I bet it's going to be more.
And then learning the concept of the numbers on the yardstick and how those relate.
Right, and with your youngest children, it's more going to be about just the visual piece
So
of it.
that's a yardstick.
Right, but you want to definitely point out that there's numbers on it and what the numbers represent. As the children grow and expand, you want to keep introducing the same things so that they become familiar, and you take it just that much deeper. So where's the inch mark? Where's the half-inch mark?
Oh, now you're getting, once you start getting into those fractional parts of an inch, now you're talking about something that kids are going to need to keep understanding for the rest of their lives. But the sooner they're introduced to it, the more comfortable they are with it also.
And they might not remember that, but later on they'll say, oh, I remember when we talked about an inch and a half inch. And just having that experience and that exposure. It's all about exposure.
And I know we've got another video, and a lot of times kids are playing in the sandbox.
Oh, yeah.
So let's take a look
My
at
favorite
this.
place.
Sand. Camilla, this one holds the same amount of sand as this one. They're the same size. They're the same. This one, it's taller, but what about this one? It's shorter, but look at the inside. Which one is same? Oh yeah, look at, they don't fit inside.
I cannot scoop the mud
So they fit the same amount.
So they can see that one is obviously taller, right? And then seeing if the wideness of them varies a little bit to make the difference, things like that also.
Exactly. And again, exposure, taller. I didn't hear, but she was using full and empty. Those are also those concepts that we want children
And
to
sometimes I think what you could do is if you don't have a sandbox at the house or something like that, right? You could do things inside. You could do water.
Right.
Different containers, dried like beans or rice or something like that, also to fill containers up, things like that.
Exactly.
And then that way the kids can pour it into a different container and see it is indeed the same amount, even though the container is a little bit different.
Right. And so they have that opportunity again to talk about wide and narrow and tall and short. So it's all, again, those concepts that help children understand measurement.
And before we get to the next video, I just want to bring the attention to the books here, because there are a lot of books about math based on whatever level the students are at. And we've got It's Not Easy Being Big with Big Bird right there. And then The Inchworm.
The Inchworm.
Right? Very famous book, an award-winning book also. And if I'm not mistaken, it's been a while since I've read this one, but doesn't The Inchworm just kind of like keep going and inch his way out of sight or something like that, out of the whole thing?
Yes, the inchworm does. He flies on the bird. And but I bought this one because we have all different kinds of, all children are different in preschool. Some of them are very big, some of them are very short. And so I bought this book and I used it because we had some children that were very big.
Right.
And so it was talking about how difficult it is to be big, but it also talks about how difficult it is being short. And so the language again in there is about tall and short and wide and narrow and all the different types of children.
All right,
so it's good for social emotion.
Let's hit this last video and we're going to take a look at some measurement in the house.
Yeah.
We're going to scoot this all the way against the wall. All the way against the wall, please. Good job. All right. All right. Can you tell me what number is that? 50 and a half inches. Okay, so which one's taller? Which one? You can both say it. That one. Can you point to which one is shorter?
Me.
Okay, what other things besides this handy tape measure can we use to measure our heights? What can you?
We can do hands, Bob.
Hands?
Like-
Okay. Oh, and count the number of hands?
Oh, here.
Remember, we go palm at the bottom, and then palm to fingertips, palm to fingertips.
3,
Oh, hold on. Let's do Hattie's first.
5, 6, 7, 8, 9.
Good job.
10, 11,
Ooh, 10 and 10 and some fingertips. 10 and some fingertips.
That's 11 and.
We'll go 10.
No, that was 11.
11? Okay. All right, we'll go 11.
Oh, just cross that one off.
Okay, we'll cross that one off. All right. Now.
Me and my puppy could do it. Can you do the size of my puppy?
You want to do the size of puppy? All right, we'll do size of puppy.
Wait, puppy. Yeah.
Okay. All right, do you want to do puppies? Okay.
Puppies.
Puppies. So can I leave a mark right here?
Yeah.
Go ahead. Pick up your next puppy. Right up here. There you go. Does that work? That work, everybody?
Yeah.
All right. Can you hold your puppy?
Can I do it for my puppy?
Can you hold your puppy? All right. I'll mark here. So that's 2. Can you put it up here? Wow. Good job. Good job, everybody.
3.
Oh, good way to keep count. 3. All right. Now let's see. How many puppies?
She's full. She's full.
Okay, go ahead. Let's try it.
4.
Oh, 4. 4 puppies. Okay. Right here.
1.
Okay, how many puppies?
2.
Okay.
3. How to be careful with my puppy. 4. He doesn't like going that high.
Ooh, 4.5? Maybe
Yeah.
4.5 puppies?
Wait, no, that's 5.5.
That's 4. Right?
Mom.
4.5
Wait.
puppies.
Mom, look. 3. Mom, look. 4.
All right.
5.
So how many puppies is more? 4.5 or 4?
4.5. 4 and 8.
4.5. How many is less?
4 puppies.
4 puppies.
And nice to see how enthusiastic they were about using their puppies, because I know that to measure horses, they would use hands.
Exactly.
And they were using hands to measure themselves against the wall. First time I've ever seen puppies. Have you used those yourself?
Well, of course.
Why not, right?
course.
Anything that's at hand, right? All right, so talk to us a little bit about what they were doing and why they were doing it in different ways than some other people might be accustomed to.
Well, this is something that a lot of us do at home, right? Doesn't everybody have the little place where they've measured their children?
Right,
or
along a
club?
door frame or
Yeah,
something like that.
exactly. So that's something that parents can do at home. I think what's key is the questions that Tad asked, like which one is taller, which one is shorter, how many, and you could even go into how much more
Right.
is this one taller than that one. And then, of course, they used their measuring tape, but they also used those non-standard units of measures with the hands and then the puppy.
Right, and that's something that they're comfortable with also, and it gets them more into it and excited, and they're doing math at the same time.
Right, and if they date that, then in 6 months, they can go back and measure again and see
Well,
where
they'll
the
be
growth.
world famous after this,
I
going
think
out all
so.
over the place. But anyway, let's talk about the shoes and what's going on. One of the activities that you can do, and anybody can do,
At
because I've
home.
done it in second grade
Yeah.
in my classroom many moons ago in second grade, but we did do shoes just like you're doing here.
Well, and again, it's whatever you have at home can be measured. It doesn't have to be just, measuring sticks or like we talked about, those non-standard. So this is shoes that I brought from home. This is Son. This
Okay.
is Alex. This is Mark, and this is Julie.
Okay.
And, you can do a lot of things. I drew a box around each of them. So children, if you took these off, you could then say, does this one go here? Oh, why not? Well, it's too short. Okay, where does it fit? So you can do matching, but what we've also done with this is we've started children looking at the graph.
Right. So
You
you've
know.
got a bar graph going on.
Yeah,
So students are getting introduced very early to looking at and interpreting graphs.
right.
And then you've got the numbers on here so they can associate that also. They can see how much more or less one is compared to another one.
Right. So there's a lot you can do with just things that you have at home. Plants outside, as they're growing, you can put a measuring tape in the ground and see how tall it is and come back later, maybe in a couple months, and see how tall that plant
It's
is.
endless, the number of things that you can do. And
It's
just like we
endless.
talk about here on Do the Math all the time, every single thing has got some math incorporated into it. Find it.
Right,
right?
exactly.
And we certainly do appreciate you taking your time and coming to talk to us about early childhood education.
Oh, it's always a pleasure.
All right, so Julie, thank you once again for coming in. We'll be back with more right after this.
Reducing pollution in a farm's water supply, improving the efficiency of a rural electric power system, discovering a new way to extend the life of a tomato. These are some of the projects an agricultural engineer might work on in the quest to make agricultural operations as efficient and productive as possible. Most agricultural engineers work in offices with frequent research visits to farms, labs, or rural areas. They work for government offices, engineering firms, universities, and manufacturers. The ultimate goal for these engineers is to improve crop and livestock production. This career focuses on the design and manufacture of the equipment and facilities needed to reach that goal. Agricultural engineers examine the impact of plant and food production on the greater environment and look for ways to reduce negative impacts. Sometimes they even make news headlines with breakthroughs on production techniques such as genetic engineering and cloning. Agricultural engineers need an aptitude for science and technology, along with good oral and written communication skills. They rely heavily on their ability to recognize and solve problems. A bachelor's degree in agricultural or biological engineering is the entry-level education needed. As the world population continues to expand, the need for the work of agricultural engineers will only continue to grow.
Always nice to talk about early childhood education, and we have fourth grader Alex with us today. Everything going well?
Yeah.
Do you remember doing any of that kind of stuff, measuring with different things?
Yeah.
All right, good. Well, do you remember how to do that problem up there? It's one of your homework problems.
Yeah.
All right, go over there and explain to Cece how to solve that.
What in the world are we doing?
We're doing this question, so we're like they already took 80 out of this, so you would put 9 in there.
Okay, because here's the thing, and I don't know, just give me a minute. When I first looked at this, I was like, 80 divided by 9. 80, it's not a nice solid, integer, and that really threw me. And then I looked over here and I was like, oh wait, that doesn't divide nicely either. And so I was really thrown. So you're telling me that because this is 80 and that's 89, we need to put a 9 there?
Like they're separating this.
Okay, because they just separated that, because each of these is being divided by 9, so they're showing that we can add them together and then divide by 9
yes,
afterwards?
they're using that.
Ah, okay, I like it.
For the, putting that.
Okay, so go ahead and fill in that box. Nice.
There you go. Great job. So, Cece, what I want you to do is I want you to throw them off. If you can, erase the box and the 9.
Okay.
And
Yep.
put X. All right, what do you do now, Alex?
Remember what we talked about earlier? We said, oh, it's an N, or it could be a box, or it can be an X, or a Y, or a Z, or any sort of, you'll see a lot of things.
It could be a circle.
It could be
Right.
this, it could be this, it could be all sorts of things, but it's still just,
Still 9.
what is it, right?
Still 9.
So it's still 9. So my answer would be X equals
9.
So show me that. Go ahead and write it up there, just so we have it nice and pretty. X equals.
There you go. So as you're doing your fourth grade problems, we just want to get you introduced to what it's going to look like as you keep going in mathematics, all right? Nicely done. Let's learn about one of the other schools in the CSU system.
No barriers has long been our clarion call here at the beach. It's our charge, the marching orders we've embraced to clear hurdles for all students. We take our role seriously because we know there are no barriers to the heights they can reach. Cal State Long Beach is a force for good, providing pathways of opportunity to all who come here. It's why we're third in the nation for advancing social mobility. It's why, through the Long Beach College Promise, we help Long Beach Unified School District students find their way to higher education so as to become contributors to the economic, cultural, civic, and artistic development of our region.
My name is Jocelyn Soto Rivera, and I'm a first-gen college student. I'm looking to get into law, so maybe go to law school after this and become a lawyer. The university helps first-gen college students because they offer a lot of support through the resources, and every single teacher I've had has paved a way for me to taught me how to navigate those waters. This is going to help my family because I have 2 younger siblings, so they're going to be able to see that if I was able to do it, they're also able to do it. So I'm great to be proud of that big sister that's able to show them the way, that it's not that hard and it's not that scary.
The beach is authentic in its equity and inclusion. As we mirror and welcome the world around us, it's why we're pioneers in the CSU for accessibility and number 8 in the nation for campus diversity.
That's specifically what attracted me to Cal State Long Beach, because I didn't feel like I was gonna fall through the cracks or be left behind. Being an autoimmune, where every single day is different and it's not always super visible to someone else, I don't think I would be able to go through college without BMAC. BMAC reached out to my teachers for me. They really do help and take over when you're not able to.
We are partners, creators, and motivators in our region. We open our campus through artistic offerings, cutting-edge museums, championship games, and on-campus clinics that combine education with practice.
Speech and language therapy can be quite expensive. This is a really good opportunity for people who need help obtaining those services, but they can't afford to financially.
We have a client for the entire semester. That's really helped me develop my clinical skills.
When you are in classes, you learn frameworks and theories of how to do something, but when you're in front of a person, it's completely different. So when we are able to meet a client and get their background information and actually practice all of these things, it sets us up for a more successful career.
The beach is a catalyst for our state and our communities. We're reshaping the workforce as our graduates make an indelible economic impact on California and the nation.
Every billionaire in the world wants to figure out how to do space travel. There are all the traditional companies. There's a lot of disruption going on in our industry. The good news is that you go to Cal State Long Beach and you don't even have to go far, right? You've got Space Coast, you've got all of these great opportunities right here in Southern California. We're trying to figure out how to do things that haven't been done before. You need people from all walks of life and different backgrounds to contribute. And so where better to start than a school like Cal State Long Beach when we need to do recruiting. The one thing that I really enjoy about students from Cal State Long Beach is that they come out a little better equipped because so many of them are working, or they're the first students in their family to actually go to college. And so they have a little more grit, right? A little more perseverance. They understand a little bit more about the world, and I think that they adjust into our industry. And I feel like the students that come out of Long Beach are ready to hit the ground running.
There are no barriers to the power of a beach education. It's why we're first in the nation in student outcomes. No Barriers is also a door to something bigger, a comprehensive effort to engage fearlessly in the next era. And as we move forward, we redouble our efforts here at the beach to hold our charge close and be innovative as we prepare and embolden our students to thrive in rapidly changing and challenging environments. Go Beach!
All right, well, before we get back to Alex, we have some breaking news. All right, this is hot off the press, brother. You know what's going on? No. Breaking news means it's pretty important, though, don't you think? Have you ever heard of the Toy Hall of Fame? No? Well, it's a big day for you, too, all right? So yesterday, they had 3 new toys introduced into the National Toy Hall of Fame. My Little Pony. You ever heard of it? Okay. Transformers. You ever heard of those? All right, very good. I've heard of both of those also. Phase 10. Have you ever heard of that? Well, yeah, it's sitting in front of us. But before this, had you ever heard of the game Phase 10? I had not heard of it either, right? So congratulations to those 3 toys. My Little Pony, Transformers, and Phase 10. So Phase 10 is a game card, it's a card game, and when I looked at it, it kind of reminded me of Uno. Have you ever played Uno? So there are different colored cards, and they have numbers on them. There's wild cards, and skip, and flip, and backward, all sorts of different things, right? You're cracking up. I'm speaking the truth here, right?
Okay.
So, Phase 10, you have played this once, but it was many moons ago.
It was a while back. Yes.
All right, Alex and I are rookies at this. So the rules of Phase 10 are you get 10 cards. Then there will be one placed face up off the remaining cards. On the screen, we can see the first thing you have to do is you have to get 2 sets of 3. So meaning you have to get 3 numbers that are the same. Okay, so maybe I have 4, 4, 4. All right, they can be different colors. All right, and I need 2 sets of 3 that are the same. Now you have to get that before we move on to the next phase. Does that make sense? All right, so when the card comes up, we'll have you go first because you're to my left, and then we'll have Cece go. All right, so what we're going to do is we're just going to lay our cards out.
Okay.
And we're going to kind of lay them out so that the camera can see them. And we have 10 cards each. And Cece, if you want to maybe flip some of your numbers so that the larger number in the center is the one facing John in the camera.
I could do that.
So you had it right the first time, right? So you want the line on the bottom. Does that make sense? That's how you differentiate between the 6s and the 9s, all right? So let's throw it, and that's yours? There you go. So here's what we're going to do. We're going to kind of keep yours together like that, all right? Otherwise, Cece's going to see the one.
I'm going to start stealing. I'm going to start stealing cards.
All right, so we have a 5, all right? So do you have 3 of a kind? Do you have a set of 3?
These 2.
Okay, so you can take your 6s, right? So let's take those and kind of put them off to the side, or you can put them up front here so that you've got those, all right? Do you have another set of 3?
No.
No. All right, so what do you have left?
Well.
So you look, so you have 2 12s and 2 5s. Now the skip means you're going to skip anybody you want. So you can make Cece skip a turn, or you can make me skip a turn. I know you wouldn't do something like that though. But more importantly, you have a wild card. And the wild card can be anything you want. So do you have another set of 3? Are you sure? Okay, so put your other set of 3 right up there, because you're making that wild card at 12. And that's good because you want to get rid of your high numbers. Okay? Now, you only need 2 sets of 3. Do you have 2 sets of 3? Yes, you do. So, Cece, let's see if you have any sets of 3.
I have 1. I got some 4s.
All right, so you've got 3 4s. So you've got a set. All right?
That's it.
All right, so let's see what I've got. I've got some 2s. I've got some 3s. I've got some 9s. So I've got a set of 9. And I'm going to use my wild card. What do you think I should use my wild card as? I've got 2, 11, 3, and 4. What should I use this with?
2s.
The 2s. Why the 2s?
Because there's 2 of them.
I've got 2 of them, so then I've got another set of 3, don't I?
So my question is, going back to that discussion we had earlier about bigger and smaller, you said we were supposed to get rid of our high cards first.
Correct.
So
Well, he wanted me to do 2, so I'm going to do 2.
I'm just asking the question whether we want to maybe switch it up and have
so I'm
the
going to
3s.
let the man ride on this
Okay,
one
all
right now.
all
So he's got a bunch of 2s.
I'm
So
just asking.
for the first phase,
Yes.
you have a set of 3. I have a set of 3. You
Yeah.
do not have a set
I
of
do
3,
not.
so I don't know how,
Right.
but anyway. So let's move on. So we continue doing that, and then you start taking the numbers that you've got and subtracting them or adding them up to your total. So I think like numbers 1 through 9 are worth a certain number of points. Wild cards are worth numbers and things like that.
Yeah.
All right. So then what we do is we take the cards and we're going to shuffle them up again.
You good at shuffling?
I'm not good.
Oh, there you go.
He's kind of good.
These are brand new cards. All right. How you doing with those? Pretty good? You feel good with this phase 10? All right, so that was pretty easy first phase, right? Alex, take a look at the board and tell us what the next phase is.
1 set of 3 plus 1 run of 4.
Okay, so a run means we have to have numbers in order. So it could be 1, 2, 3, 4. Could it be 5, 6, 7, 8? Could it be 9, 10, 11, 12? Could it be 1, 2, wild card 4? It could, right? So here's what we're going to do. We're going to 10 of them. Whoop.
Oh,
that's a nice
man. Oh, man. Congratulations.
You know what that is when a card gets tossed over like that by accident? They call that a Mickey deal. Right? A Mickey deal, you have to do it all over again.
No.
Yeah, he says, no, we're not doing that again. All right, let's flip them over. We're going to flip them over anyway, right? So let's see what we've got.
How many did you? Oh my gosh! Look at how many he got. This is amazing. This is amazing.
All right, so we need a set of 3 and a run of 4. So, well, you go first. Do you have a set of 3? I don't know if you want to use all those, right? Well, you have a wild, wild skip. So those aren't all 3 the same. But can you make a set of 3?
Yeah.
What is this with the assistants?
It was over here out on the side.
All right, so you've got 3 5s. All right, so you've got a set of 3. Do you have a run of 4? Okay, so now this is going to be a 9, and that's an 11.
Oh, now who's helping?
And you have a 1 and easy. I'm just putting it in order for him. I'm not going like this.
Okay.
All right. So you can go 1 something, 3 something. You'd have a run of 4. You could go 9 something, 11 something, or you could even go
something 9.
something. Right. So you got a lot of different options here. All right. So what's your run?
1 wild, 3.
So what do these stand for? I mean, you just can't go 1 wild, 3 wild.
It's a box. It's a box. What's in the box?
What is that? What's that going to count for now?
What number is it?
2.
Okay, so that's a 2.
And what number is that one?
4.
And that's a 4. Good. All right. So you've got your set of 3 and a run of 4. Do you have a set of 3?
I don't want to talk about it.
Well, we can see now.
Well, I have a run of 4.
Okay, so you have a run of 4.
I got a run of 4.
You have a set of 3.
No, but I got close.
Okay, so I've got a set of 3 and a run of 4, 8, 9, 11, 12. Not going to help me, is it? Do I have a run of 4? 8, 9, 11, 12? Am I missing any numbers in there?
No.
1, 2, 3, 4, 5, 6, 7, 8,
8,
11,
9.
12. That's how I count.
What comes after 9?
Oh, 10.
Oh, 10, right?
It's like,
Otherwise I'd have
like
a run of
I'm
5,
missing a
all right?
finger.
So anyway, I came close. So who won that round?
Me.
Yeah, think you up there,
Yeah.
Hotshot. You won both of them right there in a row. So let's take a look at the different rules that we have. So we have different phases. So the next time we would need a set of 4 and a run of 4. A run of 7. We only have 10 cards. That means 7 of them have to be in a row. So that's where picking up cards is going to be advantageous right there. All right? So you can see all different 10 sets that you need to do. So a set of 5 and a set of 3 is the final phase you need to get to. So something brand new for you right there. So did you learn a little something today? Good, I'm glad you. It seems like you learned a lot today, right? I know I did. Did you have some fun today?
Yeah.
All right, you know what you are? You're now an ambassador for Do the Math. You know what that means? You have to tell people about Do the Math. Can you do that for us? Good. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.